Okay, I'm going to create a start to finish recording of making this drawing sheet of the piece called the cow catcher. For this piece, we have 4 orthographic views, kind of from our standard projections. We've got this one being the front, the right, the back. We've got the top, and then we have a front, top, right isometric. All right, it's in the top view that we're going to be able to dimension kind of both the dimensions of this top face as well as the bottom face. We can't see the bottom face, but it is bigger, and so you basically have a larger pentagon on the bottom parallel to this top face. So this is providing the dimensions of those. The front view is giving us the height between those two surfaces. This was created using the loft tool. The right view is allowing us to see the distance that the tabs on the back stick out, as well as the detail of the chamfered edge. And on the back, we're able to locate and size the tabs that are on the back. Now, these little recesses on these angled surfaces on the front, little trapezoidal recesses, we wanted to understand the exact dimensions of that. And so to dimension a feature, we should be looking at it in its true size and shape, so straight on. In all of these views, we're not looking at it straight on, so the phenomenon of something being foreshortened is what's happening. So, and we won't get accurate dimensions from Onshape if we try to dimension anything there. So we will create a view, a named view that looks at that straight on, and that allows us to get kind of that offset, which was consistent all the way around. And then we will slice through it, and that'll give us a view that we can now see the recess depth. So this little white spot is how far in that went, and then we can also see kind of the shell thickness because this piece is hollowed out. So that's our plan. So let's get on with creating it. Okay, so we're going to hit Insert Sheet to add a new page. We're going to go to Insert and then Insert again, and you may have to expand the Part Studio. We're going to find the cow catcher, and the name of the view you need is going to be based on, the orientation in your Part Studio. Mine happens to be front. If you're not sure how to get this view, then just go back to your Part Studio and look at the cow catcher straight on, and then look at your view cube to see what surface of that view cube it is. Okay, so I'm going to bring this one on. Onshape is going to automatically switch to project, and I will project all those other views right now. All right, so and that view is already selected for the first time. So I'm going to project up. That'll give me my top. I'm going to select the front again and go to the right. That'll give me the right view. Now to get the back, if I were to choose the front again and go to the right, I would just get the right view again. Because when you project to the side, it's going to be a 90-degree turn. I need to flip this 180, so I actually have to start with the right this time. So I'm going to project the right and go to the right again. That will get me that next 90-degree turn to show the back side. And then lastly, we'll use project to go diagonally up and right to get the front, top, right isometric. I'm going to turn off the project tool. We're going to right click on the isometric. We're going to choose show and then show shaded. Okay, so let's go ahead and create these views over here. So I'm going to go back to the Part Studio. And the issue here, I guess if I stayed on the drawing sheet to know there is an auxiliary view tool. The problem is it's not going to work with this face because this is actually at a compound angle. So you can try it, you're just not going to get what you want. If this surface wasn't angled both from the front view, from front to right, also from bottom to top, is angled. If it wasn't like that, you might be able to use that auxiliary view tool. Okay, so it's fairly simple though. The idea is we shouldn't see on any of the 4 kind of edges of the recess, we shouldn't see this little face on any of the 4. So if I can see that face on any of them, then I'm kind of angled and I'm looking at it straight on. So if I can see that right one, right, the right's too far back, so I'm trying to get it so I can look straight on. Well, instead of you trying to sit here and feather this mouse and get it to be kind of close or almost exact, Onshape's made it easy for us. We're going to choose the surface, okay, that we want to look straight at which means normal to. Our line of sight will be perpendicular to that surface. We're going to right click on it, and we're going to choose an option called a view normal to. Okay, and now we're looking at it perfectly straight on, and if you zoom way in, you're going to notice that you can't see any of those faces on any of them. Okay, so we're perfect. Now the only other thing that I wanted to do, I got to be careful here too not to accidentally orbit anymore now that I've got that straight on. But I can rotate using these arrows, and that won't mess it up. My preference was to get this edge to be horizontal for the sake of doing my drawing. Okay, and there was a way to do that. So if I select it and right click on it, there is not an align with horizontal like I want, but there is an align with a vertical. So no matter kind of what angle this is at, it'll snap it to vertical. And you think, well, that's not what I wanted. Correct. But every time you click this arrow, it goes 15 degrees. And I really am trying to go 90. And 15 is a factor of 90. So now I can click this 6 times and I will land on horizontal. Okay. So I can get it to horizontal. This is now the view I want. So the question is, how do you get Onshape to memorize this view so that you can access it and say, this is what I want to put? Because this is not your standard view. Look, this is not the front, it's not the right, it's not the top, and it's not the front and right equally weighted. So this is not your isometric. The front looks stronger than the right, and the top looks the least of the three in terms of how much of each is kind of being presented. So this is not an isometric view. Well, to memorize this camera angle, Onshape refers to this as a named view. So if we go to this little view cube menu, this drop down, there is a thing called named views. And so we can simply type a name for this. So I'm going to call this the demo auxiliary. You type a name, and then you hit the little plus button, and it adds it to a list of views. So obviously I've done this before. Then you go back to your drawing sheet, and we're going to use the insert view tool again. I'm going to go to insert and choose the cow catcher again. But instead of view orientation being the front, I'm going to click that. And I'm going to be able to find the one that I just created. So I called it demo auxiliary view this time. You can see I've done this before, showing people. And this one I put up here in this corner. Now that we're looking at that straight on, I created a section view. And this section view, I've got to go right or left. I don't know which, I think I went to the right. If I went back and looked at my other example, I think that's the way I went. Okay, the big question that everybody asks is, how do you get this to be down here? Because right on my example, you'll see that it was down here. But if you try to grab this and drag it down here, that happens. Well, this view is generated from this view. So this one's considered the parent, and this one's like the child. And the child has to stay aligned to the parent, unless you go in and edit that setting and say, hey, I'm going to give it freedom. So for right now, if I move this one, the other one moves down. So if you double click on it, this view property menu comes up, and inside here there is a suppress alignment with parent. So right now it's forced to be aligned. If we check this box, we suppress that relationship and we give it freedom to move around. Okay, so I checked that box and I brought it down here. And then people always ask, how do you get that little box around there? And when it wasn't needed, but I was really just trying to differentiate that these two views are not part of my standard projections. And so up here in the ribbon, there's just some standard drawing tools like line, circle, rectangle, etc. So I grabbed the line tool and I just started on the border and just made a little line. That's all I did. All right. So now let's get on with dimensioning. So I'm going to dimension here. In the top view, we're trying to give the detail of the size of the pentagon. So the top pentagon, there's its width, the distance, kind of the depth from that back edge to that point was that. The depth here of this little edge, which you can see is aligned to the bottom as well. That's all the same. Okay, and we maybe wouldn't know that these two edges are equal, so I really want to locate that that point is in the middle. Okay, now for the bottom, I can go from the left to the right, and that'll give me the overall width of the bottom. The overall depth of the bottom is from here to that point. And it should be pretty clear that that's vertical. I don't think I even put that dimension on there to that point because it's pretty much a vertical line. So I think I'm going to leave it like that. Now I can go back and neaten these dimensions up, change the spacing a little bit if it's crowding my isometric, or I can move the isometric as well, right? So you want to move things a little bit, just give space for your dimensions. Here I notice that these two dimensions are a little tighter to each other than these two, so I'm going to bring the 1.2 up a little bit, just kind of help balance my spacing. All right, I just pressed D to turn dimension on again, and now I'm going to go from the bottom to the top and give that vertical dimension. So if I were to sketch those two pentagons on planes that are 0.75 apart, that's how I will loft to them. Okay. On the right view, I was going to show the distance of the tab, and I want to be sure that I get the very end of the tab and not this line. This represents the end, kind of how far out I would have extruded, and that was 0.125. So make sure you get that. It is common that people will get this edge right here and not the outer edge. Now, there is a chamfer here, and there is a dimension tool. So underneath the menu for this, called chamfer, to show the chamfered edge, you're going to click on that little angled surface as well as a reference, so like this flat part on the end, and it will give you the chamfer note. All right, so now we understand how long the tab is. We understand that it's got a chamfered edge and the details of that chamfer. All right, on the back side, we are going to locate the tabs. So I'm dimensioning from this corner to the center marks. And that technique right there would be what's called baseline dimensioning. Okay, kind of using that left reference. This is also a datum every time. And now if I want to show the heights of these, and I may go ahead and put them over here just because there's, I don't know, that's there. From the bottom to this one, I'm going to grab the left one and then bring it to the right, because that way that extension line will go right through the other one and it make it a little more clear that those are the same without having to add two dimensions. And then I'll get the height of that one. So there you go, I've located, this is counting for both. So there's 1, 2, 3 heights, and then there's 1, 2, 3 horizontal dimensions. So that locates them, but I also need to size them. And now remember, this little circle, that's because that chamfered edge, that doesn't represent the actual diameter of the tab. It is the outer circle that's the true diameter of the tab. So I'm going to choose that one, and I will pull that up. And I don't need to do this on all three, but to make it clear that this is for all three, I'm going to double click on it, get this little note. I'm going to use the blank space behind that dimension. I'm going to add a couple spaces and then do a capital X and a 3 to say times 3. Let somebody know that this is repeated 3 times. Kind of makes it really clear that those are all the same. Okay, so those are all the dimensions in the typical orthographic views. Next up, we're coming up here. Now the distance between this inner trapezoid and the outer trapezoid were the same all the way around. So instead of having to mention it on all of them, I just did one of them. All right, it kind of, this little turn on this dimension line is going the opposite way I want, which is okay. I'm going to show you that if I feel like space-wise it's nicer over here, I can click on that little elbow and it flips. Okay. Now I'm going to double click on this one, and I'm going to add behind it TYP. TYP stands for typical. So that should let somebody know that that offset all the way around the face, that it is the same all the way around. Okay. Now that we kind of understand the size of that trapezoid, what we really want to understand in this view is the depth of that cut. So this not being sectioned, not having the diagonal lines, lets us know that when we slice through the part, we didn't slice through any material right here, and that should, hopefully we would know that that is, right, this trapezoid on the front. So I want to know how big that is. What's that depth? So that dimension will give me that. And then the overall dimension all the way around, this is my shell thickness for the whole part. And I can add a note like grab these arrows and move them a little bit. Oh. There you go. Know that the label that goes onto a view, like the section, those can always be moved if you click and drag it by itself. You can, if for some reason spacing it's in your way, if you grab the whole view, it'll kind of stay in the same relative position. But if you would like to move that around, you can. And there you go. That is a completed cowcatcher drawing. So just final stuff is just tweaking any little spacing that you think helps your drawing look more neat and organized. And there you go.